We're interested in finding bases of the column space. So finding a spanning set of a column space is the easiest thing in the world. It's sitting right there in the matrix. So for example, if A equals this matrix, the column space of A is the span of the first column the second column, the third column, and the fourth column. Unfortunately, there's no reason these columns should be linearly independent. So there's no reason to assume that this is a basis. It's a spanning set, but it need not be independent. And in this particular case, it definitely isn't independent. We have a theorem that says we cannot have four linearly independent vectors in R3. So how do you deal with this? Suppose we were looking for the column space of a matrix, and that matrix was in reduced row echelon form. Maybe something like this. And we were asked for a basis of the column space. We could observe that this second column is twice the first column. That is to say, if we call these columns V sub I, 2V sub 1 equals V sub 2. And therefore, if we got rid of this column, it wouldn't affect the span. That was part of the spanning set theorem, that if a vector is a linear combination of other vectors, then getting rid of it doesn't affect the span. And we can see again, this column is a constant multiple of this column. In particular, 6 times this column gives you a V sub 4. And again, the spanning set theorem tells you, okay, if this column is a linear combination of other columns, getting rid of it doesn't affect the span. So the column space of A, we got rid of 2 vectors, but that didn't affect the span. The column space of A is the span of the remaining vectors. What we've seen here is an example of the following. These 2 columns that I scribbled out both corresponded to free variables. This is a pivot column. This is a pivot column. This is a pivot column. This and this were not pivot columns. We're going to take this and abstract it into a theorem the pivot columns of A are a basis of the column space of A. In this video, we've stated a theorem for finding a basis of a column space. In the next video, we'll do an example.